The previous video introduced important macroeconomic topics including measuring output for a nation, aka GDP, why nominal GDP needs to be adjusted for changes in the price level to calculate real GDP, the importance of economic growth, the business cycle, unemployment, and inflation. Assuming students have mastered these macroeconomic foundational principles and concepts, time to move on to basic macroeconomic relationships. In 1936, John Maynard Keynes, British economist, published a book which would change the approach to an understanding of macroeconomics. The title of the offering, The General Theory of Employment, Interest, and Money. Against the backdrop of Keynesian ideas, time to establish basic macroeconomic relationships. So, Keynes identified the relationship between income, consumption, and savings. DI equals C plus X. Fun, more initials. What is DI? DI is disposable income. So after-tax income. Human beings work, individuals receive compensation for employment, and after paying taxes, they're left with disposable income. People who have disposable income have two choices what to do with it. C is consumption expenditures on durable goods, non-durable goods, and services, and S is savings. For Keynes, the level of economic activity in the nation is directly related to the amount of income generated from economic production. He also thought it was important to establish an understanding of how the level of consumption and the level of savings was calculated, all related to the level of disposable income. So for an individual or the country, if we're interested in calculating how much consumption expenditures take place, we simply take the level of disposable income and subtract how much was saved. Likewise, if we wanted to know how much savings took place over a period of time, typically 1 year, we just take disposable income and we subtract out consumption. These basic macroeconomic relationships are important to understanding the Keynesian view of macroeconomics. Building on the macroeconomic concepts introduced on the previous slide and the Keynesian relationship between disposable income, consumption, and savings, let's build out the average propensity to consume and average propensity to save as macroeconomic tools to understand spending at both the individual level and the nation as an entirety. Assume a person makes a certain amount of money after taxes. So they make money, they pay taxes, they have disposable income. Certain percentage of that they spend, certain percentage of that they save. These ideas are called the average propensity to consume and average propensity to save. In macroeconomics, we're generally more interested in the nation as a whole. 330 million individuals in this country, citizens of this great nation, approximately 166 million members of the workforce. How much total disposable income is generated from economic activity? And of that total disposable income, what percentage is spent, average propensity to consume, and what percentage is saved, average propensity to save? Use some simple numbers. Assume that the total income generated by individuals working in the country is $10 trillion. That would be the denominator on both the left and the right. If we're trying to calculate the average propensity to consume, in other words, on average, how much of their disposable income do Americans spend? Let's say that in total, $9 trillion was spent. So total consumption, $9 trillion over total income, $10 trillion. On average, Americans spent 90% of their income. Obviously, they saved the rest of it. So on the right-hand side, we'd have $1 trillion over $10 trillion, or 10%. Americans on average saved 10% of their income. Very important to identify the concept that the average propensity to consume and average propensity to save must add up to 1. In our previous example, $10 trillion worth of income, disposable income from Americans from working activities, $9 trillion spent, $1 trillion saved. Average propensity to consume 90%, average propensity to save 10%, 90 plus 10, 100% of the income is accounted for. Average propensity to consume and average propensity to save, introduced on the previous slide, are best examined and analyzed with actual numbers to confirm our understanding of these concepts. So remember, disposable income, after-tax income, two choices, consumption and savings. Joe Q. Public, Jane Q. Public makes $50,000 this year after taxes. Spend $45,000, save $5,000. Consumption plus savings equals disposable income. What was the average propensity to consume for this individual? Okay, well, how do we calculate average propensity to consume? It's the level of consumption over the level of income. So it's 45 over 50. That works out to be 90. This person spent 90% of their income. And they saved 5 over 50, 10% of their income. Remember, average propensity to consume plus average propensity to save must add up to 1 or 100% of income. Remember, generally more concerned about macroeconomic in total, disposable income, consumption, and savings, that relationship, the Keynesian idea, building out average propensity to consume and average propensity to save by comparing what percentage of disposable income is spent, consumption, and what percent is saved. 2021, in this great nation of the USA, $15 trillion worth of disposable income generated from roughly $22 trillion worth of real GDP. So after-tax income flowed to Americans $15 trillion. How much of that did Americans spend? These numbers are generated to demonstrate the point and confirm the theory of average propensity to consume and save. Let's assume that Americans spent 90% of the $15 trillion in disposable income. That works out to be $13.5 trillion. So average propensity to consume, 13.5 over 15 trillion equals 0.9 or 90%. On average, Americans spent 90% of their income. That doesn't mean everyone spent exactly 90%. Some Americans spent 100%. Actually, some may have spent 105% by borrowing through credit cards and such. Some only spent 80%, but on average, Americans spent 90% of their income. Whatever is not spent is saved. So if the average propensity to consume is 0.9, average propensity to save is 0.1 or 10%. 1.5 trillion over 15 trillion works out to be 10%. On average, Americans saved 10% of their disposable income. Observe international data among various industrialized countries across the globe to reinforce the concepts of average propensity to consume and average propensity to save. Remember, whatever percentage of income is not consumed is saved, and vice versa. Compare Finland and Spain at the top of the chart with Sweden and Switzerland at the bottom. What conclusion can you make? Finland and Spain actually experience what is referred to as dis-savings, negative savings, because on average people in Finland and citizens of Spain spent more than their disposable income. How is this possible? By borrowing against future earnings through credit cards and loans. At the other end of the spectrum, Sweden and Switzerland, extremely low in comparison to these other industrialized countries. Average propensity to consume, which means the average propensity to save in Sweden and Switzerland is rather large. United States falls somewhere in the middle. Average propensity to consume in the good old US of A, approximately 93.5%. That is to say, Americans save about 6.5% of their income on average. Economic thinking is marginal thinking. Economic thinking is marginal thinking because most decisions involve changes in the status quo. After establishing average propensity to consume and average propensity to save, it's important to identify how marginal propensity to consume and marginal propensity to save are calculated and what their economic importance is to this macroeconomic relationship learning. Look at the formula down bottom for both marginal propensity to consume and marginal propensity to save. Be careful, it looks similar to average propensity to consume and save, but notice the word change. Change in consumption over change in income and change in savings over change in income. Individuals and as a whole the nation, the level of income changes from year to year. What percentage of that change in income is spent on consumer goods, durable goods, non-durable goods, and services, and therefore what percentage is saved? Important to understand these concepts because we're going to employ these statistics, the marginal propensity to consume and marginal propensity to save, to calculate another macroeconomic tool known as the multiplier. Again, numbers make this far more apparent or understandable from the learning perspective. Same individual we analyzed earlier, Joe Q. Public, Jane Q. Public, they were making $50,000 annual disposable income. Notice here it says they earn an additional $5,000. So last year 50,000 disposable income, this year 55, the additional 5K in disposable income. All right. So let's assume that these individuals spend 4,000 of the additional 5,000 and therefore save 1,000 of the additional 5,000. Calculate marginal propensity to consume and marginal propensity to save. Remember, MPC is simply change in consumption over change in income. Therefore, the denominator is going to be 5,000, the additional disposable income. And for the marginal propensity to consume, the numerator is 4,000. Individuals spent $4,000 of their additional $5,000, working out to be a marginal propensity to consume of 0.8 or 80%. This individual spent 80% of their additional income, therefore they saved the rest of it. 1,000 out of 5,000, marginal propensity to save 20%. Again, notice the identity of MPC plus MPS must equal 1. Whatever percentage of the change in income is not spent is saved. Whatever percentage of the change in income is not saved is spent. MPS plus MPC must always equal 1. Look down bottom in the red. We're going to use the marginal propensity to consume or the marginal propensity to save to calculate what is known as the multiplier. More about this important economic concept soon. On the previous slide, marginal propensity to consume and marginal propensity to save was analyzed examining one individual. Let's discuss the nation as a whole. First, identify the change in income for working Americans in the labor force this year. Line number 2 where it says earns an additional 1,000 billion, that works out to be $1 trillion. So disposable income for the United States increases by $1,000 billion. Of that 1,000 billion or trillion, how much is spent and how much is saved? So let's assume Americans spend 800 billion and save 200 billion of the change of 1,000 billion. Again, marginal propensity to consume. Change in consumption over change in income. So in this case, it'll be 800 over 1,000, or 8 over 10. The marginal propensity to consume is 0.8. On average, Americans spent 80% of their change in income. Therefore, they saved the rest. Marginal propensity to save 200 billion over 1,000 billion, or 2 over 10, 20%. Always important to remember, MPC plus MPS must equal 1. If Americans spent 80% of their additional income, their change in income, they saved 20% of their additional income. Marginal propensity to consume 0.8, marginal propensity to save 0.2, 80% plus 20% equals 100% of the change in income. Down at the bottom in red, remember we're going to use either the marginal propensity to consume or the marginal propensity to save to calculate an important economic idea referred to as the multiplier. Jack goes into the jeweler's and spends $5,000 on an engagement ring. GDP increases by 5,000, but the jeweler, he's been waiting to buy his wife a fur coat, so Fred, the jeweler, he goes down to the fur coat store and he buys a fur coat for $4,000. And then the guy who owns the fur coat store, he's been waiting to buy one of those fancy Pelotons because he needs to get back in shape, or he wants to get back into his youthful figure, so he spends $3,200 on a Peloton. What has happened? This idea is what John Maynard Keynes called the multiplier effect. An initial change in spending ultimately has a much larger impact on total GDP. In the previous example, first you have the spending on the engagement ring, then the spending on the fur coat, then the spending on the exercise bike, and so on and so on. The idea of the multiplier was first introduced by Keynes during the Great Depression, not to explain why things were getting better, but to give macroeconomic thinkers a reason or an explanation of why things kept getting worse. So although it has a positive connotation, multiplier, it can work as a positive or a negative influence on the economy. But the idea is vitally important to macroeconomic thinking. Initial changes in spending ultimately have a much larger impact on total GDP. So if you focus your attention down bottom on the equation, total GDP equals multiplier times initial change in spending. So to calculate or at least estimate with numbers the ultimate effect on output, GDP, aggregate production of the economy, how much an initial change in spending creates, we have to have some semblance of an idea of what size is the multiplier. So in this little example, it says, okay, a construction company spends $5 billion on new equipment. That is our number down bottom on the right. That's our initial change in spending. So ABC Construction, they need a giant manufacturing facility. They spend $5 billion on new equipment. That's not the beginning and end to economic activity. That's just the beginning. What's the ultimate impact on total GDP? We're trying to calculate the number on the left, total change in aggregate output in GDP. The only macroeconomic tool that allows us to finish this calculation is if we know the size of the multiplier. Now, we just introduced marginal propensity to consume and marginal propensity to save. The size of the marginal propensity to consume, and of course then by default the marginal propensity to save, is going to determine the strength of the multiplier. In the previous slide we introduced the macroeconomic concept of the multiplier. Initial changes in spending ultimately have much larger impact on total change in GDP. To calculate the size of the multiplier or the strength of the multiplier, we can either use the marginal propensity to consume or the marginal propensity to save. By default, if we know one, we know the other. If the marginal propensity to consume is 0.75, the marginal propensity to save must be 0.25. If the marginal propensity to consume is 0.8, the marginal propensity to save is 0.2. But given either one of these, we can calculate the size of the multiplier. Remember, total change in GDP equals the initial change in spending times the multiplier. Several examples will be covered to reinforce this important idea. Students generally aren't the greatest fans of math. This is our little multiplier cheat sheet. 1 over 1 minus MPC equals the multiplier. So if we take 1 over 1 minus 0.9, the multiplier ends up being 10. What do we observe besides the fact that we can work around the math and not have to generate the answer through the formula? There's an important macroeconomic observation on this slide, and it's the following. The greater the marginal propensity to consume, the larger the size of the GDP multiplier. Why? Well, what does marginal propensity to consume measure? It measures what percentage of change in income will the average person spend. So if on average people spend more of their change in income, there'll be a greater multiplied effect given an initial change in spending. It's important to understand the formula, but this slide is excellent for students to review and to check their calculations on the size of the multiplier. Visualizing the step-by-step process of initial change in spending, ultimately creating a much larger change in GDP, often helps students understand the concept of the multiplier. Observe up top, what information do we know? In this example, the marginal propensity to consume in society is 0.75. That is to say, on average, people spend 75% of their change in income. Therefore, on average, people save 25% of their change in income. Can use either formula to calculate the size of the multiplier. 1 over 1 minus MPC, 1 over 1 minus 0.75 works out to be 4. Or 1 over MPS, 1 over marginal propensity to save, 1 over 0.25, again, works out to be 4. We know the multiplier in this economy is 4. Given the information that there's an initial increase in investment spending of $5 billion. See, it says $5, but down bottom it's billion. So the initial change is $5 billion. How much will that ultimately impact GDP? So company ABC spends $5 billion to build a giant manufacturing firm. But then the second round of spending will be 75% of the initial change in spending. And then the third round of spending will be 75% of the second round, and so on and so on. The initial change in spending, $5 billion, creates a much larger impact on total GDP. What is the much larger impact? Ultimately, the initial change in spending creates $20 billion of additional gross domestic product. How do we know that? Well, we could do this tedious long route of round by round calculation, or we can simply take the initial change in spending, $5 billion, times our multiplier, which we calculated to be 4. 5 times 4. The initial increase in investment in a new factory of $5 billion ultimately created $20 billion worth of economic output, total change in GDP. Thus far, we have investigated how changes in spending ultimately impact GDP. When there's an initial change in private sector spending on capital investments, businesses investing in machines, equipment, tools, and factories, there will ultimately be a much larger impact on total GDP. As with government spending, typically during an economic downturn or a recession, government increases spending on roads, bridges, infrastructure projects, building schools and such. However, what happens if the government during an economic downturn decides, instead of initiating fiscal stimulus by increasing spending, decide to introduce a tax cut into the economy? Here's the issue. If the government cuts taxes, workers, members of the labor force, will receive either a check from the government or will pay less in the form of taxes to the government. They will receive more income, but a portion of that tax cut will be saved. Remember, marginal propensity to save. So if the government cuts taxes by $50 billion, the initial change in spending is not $50 billion. It works out to be whatever percentage of that $50 billion is spent by taxpayers. And that's determined by the marginal propensity to consume. Therefore, the tax multiplier will be weaker than the spending multiplier. Now, there's a formula to calculate the tax multiplier. If we take the MPC over the MPS, we can then calculate the effectiveness or the strength of the tax multiplier. So if the marginal propensity to consume is 0.9 and making the marginal propensity to save 0.1, we take 0.9 over 0.1, and what does that work out to be? Well, there's a little trick here. The tax multiplier ends up being always 1 less than the spending multiplier. So if we are familiar with our previous formula and we like our previous calculations and we're comfortable with understanding how the multiplier is determined using the marginal propensity to consume and marginal propensity to save, you can simply use the little trick of the trade and say, okay, if the spending multiplier is 10, then by default the tax multiplier is 9. So in the example I just gave, marginal propensity to consume 0.9, marginal propensity to save 0.1, 0.9 over 0.1 is 9. But we already know that if the marginal propensity to consume is 0.9, the spending multiplier is 10. Two things to be aware of. Number one, simple to calculate the tax multiplier because it's always, always, always 1 less than the spending multiplier. Two, and more importantly, Anytime there is a tax cut or reduction in taxes, the ultimate effect on GDP will be less than an increase in spending because some of that tax cut will be saved. The multiplier sheet with questions and answers follows this slide. Little warm-up. Remember, total change in GDP is ultimately calculated by taking the initial change in spending times the multiplier. Question 1 here says, how much will a $20 billion increase in investment spending affect GDP if the marginal propensity to consume is 0.9? Step-by-step process. First, calculate the size of the multiplier in this economy. 1 over 1 minus MPC, or 1 over MPS, is the multiplier. So 1 over 1 minus 0.9, 1 over 0.1, the multiplier is 10. So if there is an initial increase of $20 billion in investment spending, 10 times 20, there'll be a total change in GDP of $200 million. Second question presents the concepts from a different format. It says, okay, assume the marginal propensity to consume is 0.8, and the government desires a total increase in GDP of $400 billion. So in this problem, you know the total change in GDP. The top left, when we're talking about variables we're trying to calculate. We're trying to calculate what? Initial change in spending in this case, because we're given the total change in GDP. So it says how much government spending is necessary to achieve this desired goal. So the government wants to increase GDP by 400. That's our total change in GDP. Right? What's the multiplier? Well, we're given marginal propensity to consume of 0.8. 1 over 1 minus 0.8. 1 over 0.2, the multiplier is 5. So if the total change in GDP desired by the government is 400, and the multiplier is 5, 400 divided by 5, if the government spends 80 billion in infrastructure spending, they will achieve their desired goal of a total increase of GDP of 400 billion. Practice makes perfect. These 8 questions challenge students to demonstrate a thorough understanding of the marginal propensity to consume, marginal propensity to save, and the multiplier. Take some time to evaluate these 8 questions before moving on and looking at the answers. Drum roll, please. How do we calculate the answers to our multiplier worksheet? Assuming students paused the video and worked on this on their own. Number 1 asks you to calculate the size of the multiplier given various marginal propensities to consume. We simply implement our formula here. If the marginal propensity to consume is 0.9, 1 over 1 minus MPC tells us the size of the multiplier. 0.9, 1 over 1 minus 0.9, multiplier is 10. If the marginal propensity to consume is 0.8, same formula, 1 over 1 minus 0.8, multiplier is 5. Reaffirms an important idea. The larger the marginal propensity to consume, the greater the strength of the multiplier. Again, because larger marginal propensity to consume, people spend more of their additional income. Question 2, same drill from the side of savings. What if we know the marginal propensity to save? What's the size of the multiplier? Formula, 1 over MPS. 1 over the marginal propensity to save determines the size of the multiplier. So 1 over 0.2 equals 5. If people save 20% of their income, the multiplier is 5. If people save slightly more of their income, 0.25, 25%, the multiplier is 4. Question 3 asks you to work backwards. Given the multiplier of 4, how do you calculate the size of the marginal propensity to consume or marginal propensity to save? So 1 over 1 minus 0.75 or 1 over 0.25 equals 4. If the multiplier is 4, the marginal propensity to consume is 0.75, marginal propensity to save 0.25. Question 4. This question tells you the government spending $10 billion on infrastructure. That's given. And then it asks you, how much will that ultimately increase GDP? Well, you need to know the size of the multiplier. The question also tells you that in the economy, in question 4, marginal propensity to consume is 0.75. 1 over 1 minus 0.75. The multiplier is there 4. So initial change in spending 10 billion times the multiplier 4. GDP increases by 40 billion when the government spends 10 billion. Question number 5 is important because it emphasizes the idea that Keynes was ultimately trying to teach macroeconomic individuals trying to understand what's going on with the Great Depression. Look at the initial change in spending, question number 5. It says, assume gross business investment declines by 25 billion. What happened in 2008, 2009, because of the financial bubble bursts and because of the housing crisis, businesses weren't too keen on the profitability for the foreseeable future. They cut planned business investment. Private sector spending sent the economy into recession. So a decrease in investment spending of 25 billion with a multiplier of 5 ultimately causes a $125 billion drop in GDP. Question 6 and question 7 are asking the same ultimate outcome from different perspectives. Question 6 says, the government wants to increase GDP by 400 billion. How much do they have to spend? Question 7, the government still wants to increase GDP by 400 billion. How much do they have to cut taxes? Remember, any tax cut will ultimately need to be larger than any increase in spending. Why? Because Frugal Frank and Sally Saver will ultimately save a portion of their tax cuts. Question 6 is simple. If the marginal propensity to consume is 0.75, marginal propensity to save is 0.25, the multiplier is 4. The government spends 100 billion. Ultimately, GDP will increase by 400 billion. How do we calculate the size of the tax multiplier? We can do our fancy-wancy MPC over MPS, or simply remember that the tax multiplier is always 1 less than the spending multiplier. So the government needs to cut taxes by more than 100 billion to get the same bang for their buck, because some people will save a portion of their tax cuts. So 133 billion in tax cuts ultimately causes the same increase in GDP of 400 billion. Take the 400 billion divided by 3, that gets you your 133 billion. How much government needs to cut taxes to get the same increase in total GDP? Question number 8 simply explains everything just covered in question number 6 and 7.